Primary School.
My name is Gordon J. 8 years old, primary 2, also from Irving Primary School.
This lesson is Calculus, Chapter 5, Indefinite Integral. For the last lesson, this cosecant power. What are the powers?
Even. They are all even, and we only use some methods like
The partial fraction,
the binomial
expansion,
expansion and the
trigonal identity.
yes. But in fact, those three questions, we all need to use integral by parts.
Okay, and the powers are all on.
Yes, since last time we used even, so why now we use odd?
Well, for these, what do you think are the methods that we can use?
Integral by parts,
Okay, so mainly.
partial fraction,
Okay, yes.
and
The integral by parts are common in all these three questions.
yes. And the first question we're going to use three methods. Second, the third, we only need to use one
Method, which is the integral by parts.
yes. So the question is integral cosecant cube x dx.
For this part, this cosecant, it can be
So we can change it to the sign.
so we have this one, right?
Yep.
But what can we have next? Do we put a sine square in or do we change the 1?
We change the one.
So we have like this, right?
Yes.
After that, we can separate.
Yep.
Like this.
Yep.
For this part, can we numerate the denominator times sine x?
Yeah.
And this one we also can numerate the denominator times sine x, right?
Yeah. For so next over there,
This sine square x, we can use this again, right?
yep, and the numerator,
The sine, we can put it inside the dx.
so it's like this plus the numerator, yes, go into the df,
Then for this, can we take a sine square x and put it inside here?
yes, which made a cotangent, then we have another, because it cosine square x over sine square x, so there will be a cotangent square we can put it into. And
like this.
Yes.
So
And remember the a square minus b square?
So this part we can the partial fraction, right?
Yes. Yes.
Also, right now for this part, what can we use? Integral by parts.
Yeah. And remember, you do the first two methods, and I'll use the third method, and the second, the third question you solve.
So we have like this, right?
Yup.
For this part, we have, can we integrate?
Okay.
Which will become the logarithm, right?
Yes.
Here is a so here this part is actually on the denominator, right?
Yes.
And this will be at the numerator, right?
Correct.
So it will be like this, right?
Yes.
Then at this part, cotangent is the cosine over sine, right?
Yup.
So we can write it like this.
Yes.
Okay, next for this part, we use the, do we have the double angle formula?
Yes.
So it will be like this.
Yes.
Then this part still the same. Right now at this, cosine to the power of 4x and this. So what can we actually have? Cosine square x. We can use this, right?
Yup.
Is this correct?
Yes.
Well, actually for this, 2 and 2 can simplify. Then after that, this negative can make it reciprocal. And the 2 take down. Okay?
Can. And plus, can we simplify the two?
Wait, so this is actually sine half x over cosine half x, right?
Yes. Wait, we can make a tangent.
So right now at this part. This separate, okay?
Of course, can.
So this is the first part.
Yes. Correct.
Second part.
Awesome.
Third part, right?
Excellent. So now, calculate these three.
Well, actually, for this, you can move it there, right? But because this is the same, right?
Yeah.
Remember, this plus 1/3. When it comes here, it will be minus 1/3, right?
Correct.
So here will be a 2/3. Then you times 3/2, so here also times 3/2.
Yep.
Then next for this part, this integral dx over sine x is here, right?
Right.
Which is actually equal to this. Like this. Then after that, for this part,
Great job.
like this is it, right?
Yep.
So these two minus, which will be left with 1/3, right?
Yep.
Then this times in. But remember, sine x, cotangent cube x. What can we write this as? Okay, so here you have this sine x. Remember, cotangent is cosine over sine. So you cancel one of the signs, right?
Yep.
So that means it is cosine to the power of 3x over sine squared x, right?
Correct.
You can have this extra cosine x here. Then it can be like this, right?
Yep.
Like this.
Yes.
Then actually for this part you can write it as another way, in another way, right?
Yep.
But if you want to write it in another way, do you know how can we write it?
We can write it as cotangent. But we also can.
So for this, cotangent square x is, you still remember the identity? Which is that cosecant square x.
Oh, I got it. That means square.
And then here is actually plus this, right?
Yes.
So your plus is just like this, right?
Correct.
Okay, so this is your answer,
And
right?
how about this part?
Actually, well, for this, you can write it, you can have a cotangent, right? Can you? Can you? So it will be like this, right?
Yes.
Tangent x and cosecant x, right?
Correct.
Okay, and remember this is method 1. Okay, this is method 1, okay?
Yes.
Okay, take a look at this. Okay, so next we'll be moving on to the second method.
Write down the answer.
So it's like this.
Yes.
So can we erase all of these?
Yep. So that is method 1.
Method 2.
Method 2.
So can we put one of the cosecant square x inside here?
Yeah.
So like this, right?
Yep.
Okay, right now you have this part. Can we use integral by parts?
Yes.
Like this?
Yep.
Correct?
Yes.
Then for this part, this cotangent x, and then this cosecant x. Can we move this outside here?
Yeah.
So you'll have a negative here, right?
Right.
So it'll be like this, right?
Yes.
Well, for this cotangent x, which is the cosine over sine, just can put in. Then it's like this, right?
Yeah.
Well, right now for this, the cosine square x over sine to the power of 3x. What do you think I would use? Would we use this for this Then after that we can separate, right?
Yeah.
So it will be like this.
Correct.
Then did you realize that this part is this part, right?
Yes.
So you have 2 of this, so divided by 2. So remember this part don't have?
Yep.
After that, from here sine x, and here's the sine square x, right?
Yep.
Remember sine square x, we use this. And here you need to use minus. Then for this part, we'll need to, this part we partial fraction, right? We separate, right?
Yes. One over 4. 1 over 4.
Yeah, so here you have a 1 over 4. So it will be like this, right?
Yes.
And then for this part, we have a logarithm again, right?
Yep.
Well, next for this, we can use this one, right? Well, actually, from here, you can actually realize that it's the same. Like this, right?
Yes.
So is the answer the same? Okay, yes. So this is the second method. Take a quick look. Are you clear of this?
Yes.
Okay, can we erase this?
Can.
Okay, remember for this method too, first we already have the integral by parts, right?
Yep.
Okay, so we'll move on to the third method. So here you use the numerator and denominator times sine x, right?
Yes.
So you want to put this sine x inside, right?
Yes.
write bigger.
So now we let.
Write bigger. So right now you're using the partial fraction, right?
Yes.
So right now you can both sides times this denominator, right?
Yes.
Are you missing something? Continue. Yes. Good. Correct. Yes. Good. Wait. Yes. Yes. So what would you want to let? Okay, so you let cosine x be 1, right?
Yes.
Which one? Okay, so you're finding b, right? Yes, because that here, you let this be 1, 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0. So this is a b. Wait, 2 times 2. Yes. So this is for this. Wait, or do you have a negative? So what do you have here? 1 times 1 times 1. Okay. Then you compare the coefficient, right? Okay, you want to write out what is a plus b, right?
No. Because the one that we're missing.
Yes, it's a and c.
So let's find the coefficient of
Okay. For this is the coefficient of the cosine qx. Okay, so here what do you have? Okay, so only A and C have it, right?
Yep.
So what will it be? Remember here, positive 1, right?
Yes.
Times this negative. So is it a positive or is it a negative A? Yeah? Yes. Well, first it's not right here. Here you, plus or minus C.
So here minus, here plus or minus.
Wait, don't forget about this square.
Okay, so it will be a plus C,
This is equal to
1, 0. So that means A will need to be equal to C
yes.
so that they are both 1/4.
Okay, yeah, so you found all of these, they are 1/4.
Yes.
So we will sub in here. Wait, is the D? Yes. 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 Okay, so next this part you use this double angle formula. Wait, why do you have a +1? Okay, so right now you can continue. Yes. Okay, so right now at this part, you have the 1 plus okay. Yes. Okay, so right now at this part, you need to use this double angle formula, which will have the, yes, yes, continue, yes, then you have to over, okay, same thing, right? Well, no, I'm saying it's this, that, you mean it's a sine square. Yes. Okay. Remember the 2 you can simplify. Wait, why do you have that square? Because they're here. Here, you already take
If
a
I
half.
want the square over here, here might be a quarter.
Okay, yes. Okay, then for this you can.
Simplify.
Well, actually, for this you can just convert it to another form, right? Wait, why is there a square? So is this your answer?
Yes.
Okay, very good. So this is method 3, okay?
Yes.
Answer same?
Yep.
Yes. Okay. So this is for the first question. As you can see, these different methods, we can all get the same answer, right?
Yes.
Okay, well, for this first, we used the numerator and denominator times the sine x, right?
Yes.
Then after that, here we have partial fractions, right?
Yep.
Okay, so next, can we move on to the second question?
Okay, so we'll only use one method.
For this second question is,
So the question is integral cosecant to the power of 5x dx.
for this we can first change it to the sign, right?
Yes.
Then can we put sine square x in here?
Yep.
Like this, right?
Yes.
Then we'll use the integral by parts.
Yep.
Like this. Like this, is it right?
Yes.
Okay, this part you can think that it is sine to the power of negative 3x, right?
Yeah.
Okay, sine to the power of negative 3x, negative 3, we can take down. Then we have, here will be to the power of negative 4, right?
Yes.
Then here we have cosine, right?
Yes.
Then for this part, what do we have? Okay, cotangent is cosine over sine, right?
Yes.
So it can be like this.
Yes.
So right now, this cosine square x, can we change it?
Yep.
Then we'll separate, right?
Yeah.
So we'll have this, right?
Yep.
This part, can we just straight away use this answer? Right? Then this we can move over here. Right?
Definitely correct.
Remember this part we don't have it anymore, but we'll have this part.
Yeah.
And don't forget about this. So here you get this answer, right?
Yes.
Okay, so this is your answer. Okay?
Yeah.
This is the second question. Next, can we move on to the third question?
Yep.
Okay, let's erase everything. Okay, the third question is,
is integral cosecant to the power of 7 x dx.
Okay, also we can change it into sine.
Yes.
Like this. Then we put two of these inside. Which will be like this, right?
Yeah.
After that, we'll use the
So we will use the
integral by parts.
Integral by part.
Like this, right?
Yes.
So this can be the sine to the power of negative 5x, right?
Yes.
Then here you have to the power of negative 6, right?
Yes.
And here's the cosine. Then for this part, we can combine these together.
Yes. Awesome.
So it will be like this.
Yes.
Then after that, this numerator, we can use this, right?
Yep.
So it will be like this, am I right?
Correct.
This part still stays the same. This part will separate. So it will be like this, right?
Yes.
This part, use this sub in, right?
Correct.
And for this, we'll move to here. So there will be 6 divided by 6. No more. Remember, we'll need 2 times the 1 over 6, right?
Yes.
this?
Yes.
So this is our answer, right?
Yep.
Right. Okay, so we found our answer for the third question. Okay, did you realize that for these odd numbers, when you found this, you actually can sub it into a rest, right? Did you realize that? Okay, let's quickly look at this, okay? Okay, so we just realized that usually for these, we'll have the repeat, right?
Yeah.
You also need to sub this in with the previous one, right?
Correct.
Okay, something common is that we all use the integral by parts, which we use it over here, right?
Yes.
Okay, then we also use this, the sine square x plus cosine square x equals 1, right? Yes, correct. Okay, well, for this first question, we actually also use all of these, right?
Yeah.
Well, you see, different methods, they also can get the same answer, right?
Right.
Okay, so are you clear of all of these?
Yes.
Okay, so shall we stop here for this lesson?
Yes, and what you want to say?
If you like our videos, don't forget to subscribe to our channel, okay?
Yes.
Okay. Thank you for your watching.